Hi, it's Wednesday. This is the first week you've had a project, and I actually have not heard any questions. Kind of surprised. So I thought I'd throw out a video to see if it would answer some questions that maybe um, you're going to find that you have questions on Thursday and Friday if you're waiting. Hopefully not till then. But so when you do a project, first thing you want to do is scan the project, just all the slides and the worksheets and even the description of the presentation. Just a quick scan through so that you're aware. This first page tends to not pertain to us, but this is a little getting started. We're going to be thinking about the future. This project should take you about 2 to 3 hours. Even if it takes you a little bit longer, that's fine. You're expected to spend about 5 hours a week on math anyways, at least about 5 hours or more. Little outline of the project, what you're going to learn, some things about formulas. Again, we're just going to cruise through. So the actual assignment's going to be creating a future job, coming up with some problems and solutions for the problems that your job will have. Let's go through. Sorry, quick go through. And no, you're not done yet, but you've just done your first scan. Next, you have your project, your actual worksheet. And again, before you start typing anything, it's really important that you look through all the information and all the problems. I'm not going to scan all the problems. You can do that on your own. But I do want to point out that this particular document is important to look at as well. It's going to have links to all the documents that you are going to need for your projects, and also any other resources that you may need. Notice some are optional. And then anytime you see a sample, even if it's a sample presentation, which you'll do at the end, I strongly suggest looking at samples before you start. Think of it as a roadmap for your project. So let's quickly look at a couple things that I think might cause some problems for students. So number one, I look at this, it says give an example of a math formula. Hold on 1 second, let me log in as this. That way I can do some editing really quick. So of course you're going to make a copy, all that, make it your own. Oops. My internet is really weird today. Okay, so a couple things where it says give an example of a formula. I see stuff like this a lot. 2c equals 4, and that is not a formula, that's actually an equation. What's different is a formula solves something specific. So let's see, like the distance between 2 points, the area of a square, the area of a square pyramid, any of those types of things are formulas. So just a random equation is not the same as a formula. When it asks why do we need formulas, again, refer to the fact that we're trying to find specific information in the real world. Scroll down, sorry. These are just examples of some things that you may choose as your job in the future. This stuff you can take a look at. Now, you're going to make a list of problems, and let's look at the example real quick. So in this case, this is a grad point sample, not one of my past students, so it'll be a little wordy, but it's a good example. So here's a problem. This particular person works on deciding whether or not he or she should make it rain for the day, because in the future we can control the weather. You'll notice there's some different problems that are going to arise from that, right? There's a lot of power and control. So they had to come up with a formula. This formula solves a specific problem in case, which is to decide whether or not to make it rain for the day. This is not a real formula. This is a made-up formula, but it is a formula in that it makes some sense, meaning this person needs to decide whether or not to make it rain. And that's based on L, which is the last days since precipitation or rain, and also based on the percent of drought. Now notice in your worksheet, where is it? It's going to ask you, what are your variables for this solution, the situation? This is what we're talking about. What are the variables? Well, P, which stands for precipitation, L, which stands for the last days, and D. So that's what you would fill out in here is your specific variables. You're going to discuss how they're related to each other, whether they're inversely related together, directly related, how does one affect the other. And finally, create a formula, which again, this person did here. Now, this is important. It says solve for each variable. That doesn't mean you're putting in any values yet. You're just solving for the variable. So let's take a look at the example. Here's the original formula. Now if I say, well, I want you to solve the formula for D, you'll see that now D is isolated on the left. And in order to isolate the D, the person had to multiply each side by D and then divide each side by P. So you have D equals 1 over LP. And finally, whoops, because he has 3 variables, we have 3 different formulas here. Now we're solving for L. So now we've solved for P, D, and L. If you have any questions on that, let me know. I can show a quick example here. So let's say we were doing the formula for a rectangle, which is area equals length times width, and I said solve for L, then you would have area is width, sorry, length is width divided by area, because I'd have to divide both sides by A, and then finally W is equal to length over area. So in these cases, there's no values. It's just all the variables, unless there's a value in the original formula, like in the case of here, this one. And then there's a part where I want you to think and really come up with a good problem. This is a very good word problem here. This particular person explains their job is to decide whether or not their district will receive rain that particular day. They're giving us 21 days since the last precipitation, and the percent of drought is 53%. So now we can plug it in, right? So P equals L, which is in this case 21, times D, which in this case is 0.53. Again, this is not a real formula, but it does make sense when you read the problem and you plug it in. It makes sense. And that's the major issue I've had in the past, is students just throw out numbers and don't come up with any explanation. That pretty much covers it. So if you have any questions, kind of running out of time, it's Wednesday afternoon, it's due Friday. I will be available somewhat the next couple days. I do have other meetings, but contact me as soon as possible if you have questions.